Here's number 31 from tonight's homework. Just by looking at it, I can see that I'm going to have to use the power of a product property. And I'm also going to have to eventually use the product of powers property. But I definitely want to start with the red piece because I have to do exponents before I do any multiplication. So I'm going to remember distribute, but not distribute. So it's like distribution, but it's not technically distribution. The 2, the power of 2, to the negative 10 and to the x to the 6th. Now, be very careful here because it's negative 10 that's getting the power of 2. So I end up with negative 10 squared times x to the 12th. Anytime you have a power to a power, you multiply the two exponents. And that's all times x squared. So now I'm going to multiply the like bases. So the like bases I have are x to the 12th and x to the 2nd. Anytime you multiply like bases, you add their exponents. So 12 plus 2 is x to the 14th. I'm also going to evaluate negative 10 squared because that's a number and I can get a value from it. Negative 10 squared really means negative 10 times negative 10, which is going to be positive 100. So my final answer is 100x to the 14th. Here's number 35. I can see just by looking at it that I have a few things going on here. The first thing I notice is that I have the power of a product, which I always want to do first because, again, think of PEMDAS. Exponents comes first, so I always want to do that property first. I also see that I have two like bases, so eventually I know that I'm going to do the product of powers property. But let's again start with the red section. So when I have an exponent, I need to distribute, but not distribute it, to everything inside of the parentheses. So I get negative, I'm going to keep this in parentheses now, 2 to the 3rd, p to the 12th. Because, again, anytime you have a power to a power, you multiply. So 12 was the result of 4 times 3. And that's still being multiplied by negative 1.5 p to the 7th. So now I'm left with just multiplication. So I'm going to go ahead and multiply my like parts. So p to the 12th and p to the 7 are like parts because they have the same base. I also really have negative 1 here, which is a number, 2 cubes a number, and negative 1.5 is a number. So I'm going to end up multiplying all of those together to give me just one simplified number. So I know that negative 1 times 2 cubed is just 8. 2 times 2 times 2 is 8, times negative 1.5 results in 12. That's something you could put into your calculator to check if you wanted to. I do know that it has to be positive because I have a negative times a negative. And then when I go ahead and do p to the 12th times p to the 7th, when I'm multiplying like bases, I add my exponents. So this should be p to the 12 plus 7, or p to the 19th. Okay, so this is number 49. It wasn't assigned to you, but I would strongly encourage you to right now just grab a piece of paper, pause the video, and see if you can do this problem. This is number 49 on page 492. If you can do this problem, you are like a exponent superstar right now. So please pause the video right now and give it a shot. When you're ready, unpause the video and feel free to watch my solution. Okay, so again, I always want to start with the power of a product property. That's where I always think it's best to start because, again, I have to follow the order of operations and exponents come before multiplication. So I'm going to go ahead and distribute, but not distribute, the 3 to everything inside of the parentheses. So I'm left with negative 2s. I'm going to leave that alone for now since it doesn't have any powers to it. I have negative 5 to the third. R to the third power is r to the ninth. S to the third, t to the third. And again, that's just the result of me giving the third power to everything inside of the parentheses. Notice how I kept the parentheses around negative 5. That's really important because it shows me that my base is negative 5, which we discussed in class today, the difference between that and not having the parentheses. Now I'm going to take the power of 2 and give it to everything inside of the parentheses. So I'm left with, and again, I'm going to use parentheses around negative 2 to really emphasize the fact that negative 2 is my base. Negative 2 squared, r to the 8th, 4 times 2 is 8, s to the second, t to the 14th. And again, I attain these by distributing but not distributing the 2 to everything inside of the parentheses. And anytime I have the power to a power, I multiply. So now I'm going to go through my new equation, which has only multiplication between it. That's the only other operation that we have here. And I'm going to multiply the like parts. So negative 2, negative 5 cubed, and negative 2 squared are all like things, like quantities, because they're all numbers. S cubed, and s squared are all like because they all have the same base. R to the ninth, r to the 8th are like because they have the same base. And t cubed and t to the 14th, I'm going to do a little blue under here to make it look different, are like terms as well because they have the same base. So let's go ahead and simplify our like terms, or like quantities. So negative 2 times negative 5 to the third. Negative 5 to the third is 125. Sorry, negative 125, because negative 5 times negative 5 times negative 5 is negative 125. 3 negatives make a negative. Times negative 2 squared. Negative 2 is negative 2 times negative 2, which is going to give me positive 4. When I multiply those all together, I get positive 1,000. The reason it's positive is because this quantity is negative, this quantity is negative, this quantity is positive. A negative times a positive is a positive 1,000. Let's move on to, I'm going to go alphabetically, so I'm going to move on to my r's. R to the 9th times r to the 8th is r to the 17th, because when we're multiplying like bases, we add their exponents. So now let's move on to the s's. We have s to the first power, s cubed, and s to the second. So I'm going to add up all the exponents, and I'm going to get s to the 6th. The last piece is doing the t's. So I have t cubed, t to the 14th. So when I multiply like bases, I add my exponents, and I get t, let's be fun, to the 17th. I'll make it blue and red because that was my underlining color code. So I hope you took the time to do this and are starting to find that this isn't all that complicated once you get the rules down.